Good morning, guys. I am homesick, but I would like to try and help you with how to do your work for today before before I give up on everything. Yeah, that sounded bad. Your goal for today is to be able to graph a function given its description, to write its equation in standard form, and also to write it as a single fraction, which will require combining like terms after finding a common denominator. We will start by drawing the asymptotes. A horizontal asymptote will go side to side across 1 in this case. A vertical asymptote will go up and down over -5 in this case. So let me draw both of those lines real quick. These lines are dashed. They are not part of the function. They are simply guidelines to help me shape my graph. So those two right there tell me pretty much where my graph is going to be. That gives me the middle of my graph, that point of symmetry there. And now I need to look at the numerator of standard form to find some more information. If that number is positive, my graph will be on the top right and bottom left. If that number is negative, my graph will be on the top left and bottom right. 2 in this case is a positive number, so that tells me the two bends, the two branches of this graph, this hyperbola, are going to be on the top right and bottom left of this graph. The number 2 is going to be used to help me figure out how close to the center it is. Basically, I'm treating this like a slope and counting up to and over 1 from the middle, and again, because this is positive, to the top right and bottom left. This graph is also symmetric, which means when I count up 2 and right 1, I will also count right 2 and up 1, which will give me 4 separate points. So as shown here, from the center of this graph where those asymptotes cross, right 2 up 1, right 1 up 2, left 1 down 2, and down 1 left 2, again that 2 being the key number there, is going to tell me where my branches go through. So I can draw my parabola now, following my asymptotes going through those 4 dots. I'm fairly certain I just said parabola. I really meant hyperbola. This rational function, this simple rational function, is a hyperbola. From here I have 2 equations to write, one in standard form and one is a single fraction. So let me write down the notes you need for standard form. The standard form of this rational function will be the number I gave you for the numerator divided by x minus the vertical asymptote. That minus there will cause a sign change, and also adding the horizontal asymptote to the end of that. So for this problem, my numerator on top is a 2 over x minus a -5, so a positive 5 because of the double negative, and with a +1 at the end. So just like the idea of factors, those things with x's still tend to change signs, and that is the first function answer. That is the standard form of this rational function. Now the second thing I ask you to do is to write this as a single fraction. That means I need to find a common denominator and add these 2 fractions together. So I'll show some work over here as I start with my same equation. And for both of these to have a common denominator, that means I need to multiply my constant, this 1, the number on the right, by x plus 5 over x plus 5. That will change the shape of this without changing its value, because x plus 5 divided by x plus 5 is mostly 1. Now when we multiply fractions, we multiply only the top, the numerator. We do not multiply the bottom. This will have to be distributed, and in this case, multiplying by 1 is kind of boring. 1 times x is simply 1x, and 1 times 5 is still 5. But what this does is this now gives me 2 fractions with a common denominator, meaning I can combine the things on top. So the bottom x plus 5 as a denominator will not change, but I can add a 2, a 1x, and a 5 by combining my 2 numbers, the 2 and the 5, together, which will make a total of 7. So that means my other equation, the same equation, written as a single fraction, will be a total of x plus 7, that 1x and x on top are the same here, divided by that same numerator of x plus 5. You can check this by graphing both of these. Both of these equations need to graph in the same place on the calculator and should look exactly like the thing that we drew at the beginning. If your functions do not line up, you probably have a sign error. So for example 2, we start by drawing the asymptotes. Horizontal goes across -2, vertical goes straight down through 3. So that is the new middle of my graph. Then looking at the numerator, that is a -1, which tells me I'm only going a distance of 1 from the middle. Also, negative tells me to use the top left and bottom right quadrants of this newly created sector thing. So my graph again will follow the asymptotes, look almost exactly like those lines, but we'll go through those 2 points. There are only one point in each branch to use for the number 1, because going left 1 and up 1 and going up 1 and left 1 results in us stopping in the same place. So the graph of my function looks something like that. Standard form again is the numerator divided by x minus the vertical asymptote plus the horizontal asymptote. So I'll have a -1 over x minus 3 minus 2. Again, if you graph that in the calculator, it should look exactly the same as what we just drew. Now for the last part, we are trying to combine these two fractions. So again, we need a common denominator, which means I'll be multiplying the 2 by x minus 3 over x minus 3. Again, this does require distribution, and we are only going to multiply the top of that fraction. So in this case, the -2 will be multiplied by the x minus 3 on top. So -2 times x is a -2x, -2 times -3 makes a +6. And lastly, now that we have a common denominator, I can combine like terms. So I've got two numbers, a -1 and a 6, which will make a total of 6 minus 1 is 5. So I'll have a -2x, not changed because there's no other x's on top, a +5, because 6 minus 1 is 5, and the denominator will not change, so again, x minus 3. So there are my two functions, again, standard form on top and as a single fraction on the bottom. And again, to check, if you graph both of those equations, they should graph in exactly the same place and also match the sketch that we drew. The other 4 problems are yours to do. They are randomized. Please be sure you finish them, turn them in, and don't forget to check them. Graph them. Make sure they're all in the same place.